There are different ways to harness the sun's power. By using a magnifying glass or a curved mirror, both of which can concentrate sunlight, creating intense heat. And that's exactly what inspired the creators of Solar One to build a low-emission power plant in Nevada's Mojave Desert. In a desert where the sun shines 300 days a year, hundreds of parabolic troughs are formed by nearly 200,000 mirrors side by side in rows, reflecting sunlight with a surface area of about 65 football fields. That makes enough electricity to keep the power on in 14,000 homes year-round. The sunlight is concentrated to 70 times its normal strength. That's hot enough to burn your skin instantly. The sunlight heats oil in these tubes. And that hot oil is used to boil water, which makes steam that drives a turbine, which makes electricity. It may sound like a simple process, but there are a few problems to overcome for a solar power plant like this. Number 1, regular mirrors don't reflect nearly enough light to do the job. Number 2, the mirrors have to move all day to match the rotation of the Earth. And number 3, what happens to a solar plant at night when there isn't any sunlight? The first challenge is finding the proper type of mirrors for the job. Household mirrors are fine for touch-ups, but they're backed with a cheap spray-on coating that absorbs a lot of light. Typical laboratory mirrors use silver coatings that reflect most of the light that hits them. But the only mirrors powerful enough for this job are super high reflective mirrors like the ones used at Solar One. They reflect almost 100% of the light that strikes them. To help heat the oil tubes further, the mirrors are curved. This concentrates the light onto oil tubes that sit perfectly at their focal point. Focusing light is one thing, but putting it to work is another. So engineers cover the oil tubes in a special glass that intensifies the sun's rays even more. By the time the hot oil travels through more than 12 miles of tubing, it's 4 times hotter than the boiling point of water. The oil is now pumped into the power plant and ready to boil water. Oil tubes run down the center of these water pipes. The water absorbs heat from the oil, turns into steam, and heads straight into the machine's generating station. All of the electricity from this power plant is produced with conventional steam turbines. Steam drives the blades, which spins a generator that delivers electricity to the local grid. Once the steam has fueled the turbine blades, it cools down. It's no longer hot enough to drive anything, but it's still a vapor. It has to cool down more before it can be used again. So the steam heads to a rain room, where it is trapped, condensed, and returned to the system. The second challenge for this machine is to follow the sun's arc. If these mirrors remain stationary like traditional solar panels, they would only reach their maximum potential for a few minutes every day. So electric motors adjust the mirrors to trace the sun's arc across the sky. To deal with the third challenge, losing their power source when the sun goes down, designers are planning to make thermal storage tanks filled with heat-trapping molten salts. But those are still on the drawing board. So at night, Solar One switches to a natural gas burner to keep the turbine spinning. Thankfully, the demand for electricity peaks during the day. And that's when this machine really delivers. 60 megawatts of power with almost no emissions. That prevents 20,000 cars worth of CO2 from entering the atmosphere each year. Solar One, a giant machine that captures energy from the sun while leaving just a small carbon footprint.